Hello students, greetings of the day. This is N.P. Sagar, working as assistant professor in the Department of Mechanical Engineering, Sagar Institute of Research and Technology, under the prestigious group D-Stage Bhopal. So, welcomes you all in today's session. In today's session, we are going to discuss about the non-conventional machining processes. So, let us start the session. Yes. Now, in today's session, we will discuss about the non-conventional machining process or known as unconventional machining process, and these heads I will cover in my lecture. Definition, then what is the need of non-conventional machining processes, then classification, difference between conventional and unconventional machining processes, then type of work material, which type of work we can machine, we can process uh, through the unconventional machining process, and shapes to be machined. What type of shape on the workpiece we can machine with the help of unconventional machining process. Yes. So what is the definition of the unconventional machining process? The non-conventional manufacturing process is defined as the group of processes that remove excess material by various techniques involving mechanical, thermal, electrical, or chemical energy, or combination of these energies, but do not use a sharp cutting tool that is required in the traditional manufacturing process. Yes, so dear students, as per the definition of non-conventional process, it says that the uh, unwanted material or excess material from the workpiece will be removed with the help of utilization of some energies like mechanical energy, thermal energy, electrical energy, chemical energy, or combination of these energies. In these processes, these process do not use the sharp cutting tool that is used in the conventional machining process like lathe machine, shaper machine, milling machine. They use sharp cutting tool for removal of excess material from the workpiece. So this is the difference and between non-conventional and conventional machining processes. Unconventional machining processes, these are the techniques. Those involve different energies, and those are responsible for the removal of material from the workpiece. Yes, what is the need of the non-conventional machining processes? So this is the need extremely hard and brittle materials that is to be machined like tungsten, hard carbides, inconel, uranium, beryllium, uh, mnemonics, uh, etc. Those are very difficult to machine by conventional machining process. Yes. So if the material is very hard and brittle, like tungsten, hard carbides, inconel, uranium, beryllium, etc. So these materials are very tough to machine by the conventional machining processes, because these are the special materials, and these are also used to make some special components. Those are used some specific applications uh, like aerospace industries, missiles industries, etc. The missile industries or aerospace industries, they require very hard and brittle materials uh, as per the strength required. So these are very tough material, and they cannot be machined by the conventional machining process. So these such materials are processed with the help of non-conventional machining processes. So this is the need of the non-conventional machining processes. Now the classification of the non-conventional machining processes, how to classify, and there are also the main reason for using unconventional machining processes are, these are also the reasons: high strength alloys, complex surfaces, high accuracies, and surface finish. Yes, uh, the needs industry need the high strength alloys. Then complex surfaces are required on the different components, and high accuracies and surface finishes are required. So these are also the main reasons for using the unconventional machining processes. Now the classification of the non-conventional machining process, the classification based on the nature of the energy used for the material removal. Yes, during the process, this type of energy will be utilized, that will be responsible for the removal of material. So on the basis of utilization of energy, we can classify the non-conventional machining processes. So first is mechanical processes, mechanical energy processes. In mechanical energy processes, in these processes, the material is shaped by mechanical erosion of the workpiece material. As the material will be removed with the help of mechanical energy. So, on the basis of this energy, here are different non-conventional machines. First is AGM, abrasive jet machining processes. Second is ultrasonic machining process, and third is water jet machining, and the last is abrasive water jet machining processes. So these are the different processes, those are based on the mechanical energy. Yes, next is uh, electrochemical processes, and these processes involve electrolytic dissolution of the workpiece material, right? So in this process, there are different processes: electrochemical machining, electrochemical grinding, then electrojet drilling. After that, the next process is electrothermal processes. In these processes, the thermal energy is used that is responsible to melt and vaporize the uh, tiny particles of the work material by concentrating the heat energy on a small area of the workpiece. So first is electro discharge machine, or that is EDM, also known as electric discharge machine. Then second is laser jet machining, LJM, and next is electron beam machining. So these are the processes, those are based on the thermal energy. Then fourth is chemical processes. Under the chemical process, there are two processes: chemical milling and the photochemical milling. And these methods involve controlled etching of the workpiece material in the contact with the chemical solution. So this is the classification of the non-conventional machining processes. On the basis of energy utilization, the different processes are classified. Now, the difference between the conventional machining process and non-conventional machining process, how to differentiate them. So there are two columns. First, we have a conventional machining process, and in second column we will talk about the non-conventional process. So first difference is that under the conventional machining process, during the machining process, we all know that there is a chip formation at the microscopic level. Yes, have you seen during the machining process on the lathe machine, uh, for example, turning operation, right? So during the turning operation, the excess material from the workpiece is removed with the help of a cutting tool, and the material is removed in the form of chips, and those chips we can see. So the chip formation at micro. So here the chip formation at the microscopic level. We do not need any microscopic to visualize the chips formation. But in the non-conventional machining process, in this process, the material is removed in the form of chips. So there is also a chip formation. But to visualize the chips formation, now we need a microscope. So chip formation at the microscopic level. Now the second difference is uh, we talk about the conventional machining process. So there is a direct contact between the tool and the workpiece. Yes, we all have seen the conventional machining process. Uh, for example, lathe machine, shaper, any operation on the lathe machine, any operation on the shaper machine, any operation on the milling machine. We can see that during the machining operations, there is a direct contact between the cutting tool and the workpiece, right? But in the unconventional machining process or non-conventional machining process, there is no direct contact between the cutting tool and the workpiece, right? Here, there is a small gap between the small gap between the cutting tool and the workpiece, and this small gap is filled by some other medium. That is, yes, and during the operation, by involvement of the energy, the material is removed from the workpiece. So here is no saw cutting tool in the non-conventional machining processes. Third difference is the tool life is uh, less in the conventional machining process. Why? Because there is a direct contact between the cutting tool and the workpiece, right? And when the tool will be in direct contact, and the tool will remove the excess metal from the workpiece. So definitely after some time, the cutting edges of the cutting tool will be dull. So the tool life is less. It means after some time we have to regrind the cutting edges of our tool. So tool life is less, but in the non-conventional machining process, there is no direct contact between the cutting tool and the workpiece, right? So tool life is high. Yes, now cost-wise, we talk about the conventional machines. The capital cost is low for the in the conventional machines. Yes, lathe machine, shaper machine, milling machine, uh, these costs are low, but the cost of the non-conventional machine processes is very high. The machines are costly. Then we talk about the finishing and accuracies. So as compared to the non-conventional machining process, the finishing and accuracies are weak, right? And the finishing and accuracies are very high of the non-conventional machining processes. Yes, the components produced with the help of lathe machine, milling machine, shaper machine, we all know that they produce good accuracy. But here we are discussing about the comparison between the non-conventional machine processes. So as in comparison to non-conventional machine process, the accuracy or finishing is little low as compared to the non-conventional machine process. Then we talk about the operator. In the conventional machining process, the skilled and unskilled persons can perform the operation, right? Yes, skilled operators can perform all the operations, but unskilled persons, by giving some training to be unskilled person, and after taking some training part, after learning from the training, he can also perform the operations very well. But in the non-conventional machine process, only skilled persons are required because the machines are very costly, and the operations are very complex. So only skilled persons are required. Unskilled person operation cannot have the non-conventional machine process, and he cannot do the operations perfectly. The next difference is noise problem is high in the conventional machine process. Yes, during the operation, definitely we have a few experience that lathe machine, milling machines, super machine, they create in high noise during the run. But the noise problem in the non-conventional machine processes is low. They perform their operations very smoothly with low noise. Then use of mechanical energy or forces. Yes, in the conventional machines, when they perform the operation, or when the excess material is removed by the cutting tool, so they use mechanical energy or forces, and with the help of mechanical energy and forces, the machine process takes place. And but here, no use of mechanical energy or forces in the non-conventional machining process. And for example, no use of mechanical energy or forces. For example, ultrasonic waves in UCM. In ultrasonic machines, then EVM machines, electrons in beam, and LVM, laser in beam. So these energies are used. So this was the difference between the conventional machines and non-conventional machine processes. Then now we talk about the type of work, which type of work we can perform or we can process with the help of non-conventional machine processes. So first is all steel work material, right? So these material can be processed with the help of ECM, CHM, EDM, and form, right? Then for superalloys materials can be processed with the help of AGM, abrasive machines, ECM, electrochemical machining, UDM, electric discharge machining, then PALM, plasma machining. And for titanium overcapacities, UDM is used. For refractories materials can be processed with the help of USM, ultrasonic machines, abrasive jet machines, electric discharge machines. Yeah. So these are the machines for which the refractory materials can be processed. Then also we can process the non-metals like ceramics, plastics, and glasses. And for processing these materials, there is a USM, AGM, LVM, laser beam machining, and EVM, electric beam machining. So according to the type of work, the different machines can be used for processing the different materials. Yes. Now we talk about the shapes to be machine. Which type of shapes we need or we require on the workpiece. For example, we need a micro hole. So which type of process we should use? So the process is LBM, laser beam machining. With the help of laser beam machining, we can perform micro holes on any workpiece. Then second is Small holes, for small holes, there is a EVM, electron beam machining. Then third is deep holes, that is L by D is greater than 20. There is a ECM process. Then shallow holes, for shallow holes, there is a two methods, USM and ETM. Then precision through cavities, there is also two methods, USM and ETM. Then etching small portions, ECM and ETM. For surfacing process, there is the ECM process. And through cutting operations, ECM and palm plasma machine. Then shallow cutting, there are four methods: AGM, CHM, EVM, and LVM. Then for grinding operation, there is a FSOZ machine, FSR machine. Then for hunting operation, there is ACM. So according to the shapes to be machined on the workpiece, we can choose the machining process, non-conventional machining process. So this was the discussion about the non-conventional machining processes, and now uh, let us conclude the sessions. In today's session, we have discussed about the non-conventional machining processes through covering the different heads. First, we have defined the definitions of the non-conventional machining process, in which we have seen that the non-conventional machining process use some energies. Those are responsible for removal of the material from the workpiece. They do not use the direct. They do not use the sharp cutting tool that is used in the conventional machining process. And after that, we have discussed about the need of the non-conventional machining process. Under the need of non-conventional machining process, we have seen that the very hard and brittle materials, those cannot be machined by the conventional machining processes. So these materials can be processed or machined with the help of non-conventional machining processes. Then we have discussed about the classification of the non-conventional machining process. Under the classification, we have classified the different machining processes based on the utilization of energy, like mechanical energy, thermal energy, chemical energies. So on the basis of energy utilization, we have classified the different machining processes. Then after we have discussed about the difference between conventional machining process and non-conventional machining process, and during the comparison we have seen 7 to 8 different points between those processes. After that, we have discussed about the what type of work material we can process with the help of non-conventional machining processes. Then in the last we have discussed about the what type of shape to be machined on the workpiece, like micro holes, small holes, surface machining, shallow holes, deep holes, right? So this these all things we have discussed in today's session. So thank you very much, and next session we will meet soon again. Uh, Thank you.